In emergency situations, quick access to accurate information can be critical. A web app that accepts both text and image inputs allows for intuitive interaction, particularly in stressful situations where typing detailed descriptions might be challenging. This could be especially beneficial for users who are visually impaired, have limited mobility, or are not native speakers of the language. This innovative approach leverages technology to make medical information more dynamic, accessible, and practical, bridging the gap between laypersons and the often complex field of medical care.
Aide-N is an online assistant that aids in identifying injuries using Gemini's 1.5 Pro's image-to-text function. All you have to do is upload an image, which can be done on our homepage, and click Generate. Aide-N then uses that image to generate a detailed description of the injury using the Gemini Pro and Gemini Pro Vision models. Aide-N also generates a potential solution or treatment to the certain injury identified based on the output of the image to text.
Here I have an example picture of an injury, and I'm going to put it into Aide-N. Aide-N will take the image, and here you can see an output at the top. This is Aide-N's interpretation of the image. It then outputs a set of instructions based on this interpretation of the injury and how to treat it.
Furthermore, there's also an option to ask Aide-N any questions you might have regarding the injury treatment instructions. The question response is based on the context of the instructions, so you can ask it to clarify any intermediary steps. Lastly, Aide-N also provides more information through a useful link provided at the bottom of the page.
The next phase of Aide-N is being able to provide a potential solution to the injury at hand. To do this, we use our own large language model backed by Intel to take in an existing dataset of medical injuries and solutions in order to train a model on being able to classify these descriptions. The LLM runs on Intel's developer cloud with the PyTorch GPU and takes in the textual description of the injury while sending an output of a textual solution. To do this, we tested different types of learning, including zero-shot and few-shot learning, after retrieving the dataset from Hugging Face.
Being able to connect everything together required us to implement Intel's small VM Xeon 4th generation scalable processor, which allowed us to run on the cloud. Along with this, overall, the technologies used include Google's Gemini, Intel's developer cloud, Intel's large language model, Intel's extensions for PyTorch, and Hugging Face to deploy a working LLM model.
To display all of the Python code, we set up a Flask web app that takes in the image processing functions. We then implemented Flask routes to handle GET and POST requests, which is then rendered onto the resulting HTML file. For our final app, we were able to implement image uploading, image analysis, instruction generation, a source link for more information, user interaction through a chat input, and response generation.